This is the smallest ESP32 drone kit you can actually build. The ESP-FLY, a quadcopter small enough to fit in your shirt pocket that you can fly with a real radio controller or even your smartphone. And now there's a DIY kit that makes it way easier to get one in the air. I designed it to be a simple, hands-on way for you to get into drones and learn how they work. After the open source project blew up, Seed Studio and I turned it into a kit with the hardest parts already taken care of for you. I'm Max, and in this video I'll show you exactly how to build and fly it. In the box, you get a thumb-sized microcontroller, the XIAO ESP32S3 as its brain with an antenna, the sensor/motor driver module, 4 brushed coreless motors, a set of propellers, a 250 mAh LiPo battery, power and landing gear wires, a zip tie, sticker, and the 3D printed frame with top covers. To get the complete kit so you can follow along, check the link in the video description below. The assembly is straightforward and beginner friendly, provided you have the bare minimum tools required: a soldering iron with some tin, a pair of flush cutters, a hobby knife, and tweezers, which can all be found in one of those budget soldering kits you can get online. Let's start by assembling the flight controller, which involves connecting the microcontroller to my custom designed 2-in-1 inertial measurement unit and motor driver module, with all of its tiny components pre-soldered in the factory for convenience. Heat up your soldering iron to 300 degrees Celsius and use a solder fume extractor or a fan coupled with a nearby window to protect your lungs. Secure the microcontroller to a surface with some double-sided tape or use a set of helping hands. Then strip the ends of the power wires using your hobby knife. After tinning the tip, pre-tin the battery pads and the ends of the wires. Solder these wires by preheating a pad first, then pushing the wire onto it and applying more heat on the wire to melt it into place. Repeat this for the other one and flare both outward. For the sensor and motor driver board, pre-tin its battery pads and solder the wires from the XIAO with the red one to B+ and black one to the B- pad, following the same principle. These wires ensure the power from the battery is shared between both boards. Rearrange the wires with some tweezers so both can be sandwiched together with the connectors of each board facing the same way. Now stick on the microcontroller on its back. Push down on the green board till it touches the pin header rows, and tack one corner down by soldering a pin. Do the same for the pin on the opposite corner, keeping the board secured, and continue soldering the rest of the pins by applying heat on the pad and pin at the same time. Then push in some tin, not so much on the soldering tip, but rather on the pad so it flows all the way around, forming a clean volcano joint. Holding the iron tip long enough after adding tin ensures an even joint forms around each pin. At this point, plug in the battery to see that everything lights up. Trim the pins with a pair of flush cutters as close as possible to the base while holding each pin with a finger to prevent them from splintering away, and the flight controller is complete. Next, let's secure the battery using a zip tie, which by default won't allow the flight controller to fit all the way in unless you slice away a millimeter from the head with a hobby knife. This still leaves enough plastic for the tie to stay locked. Then lace it through with the head inside the frame, slide the battery through and tie it down enough so the battery is secured while allowing for it to slide in and out for replacement. Trim the excess with a blade and the battery strap is done. Now for the motors. We have one clockwise and one counterclockwise pair. Push each through the bottom into their holders without any glue in this order so each pair sits diagonally from one another. Then you may want to widen these little holes with the tweezers so the motor wires can fit through into the frame. Once through, flare them out, put the flight controller on top, upside down. Pre-tin its motor pads and then swap each pair of wires around to match the motors to the pads that are meant for them. Follow this same polarity based on wire color, apply minimal heat, and ensure you don't leave any exposed wire to short with the outer pads. Now untangle the flight controller, flipping it around to where you can see each motor has been wired to the correct terminals. Get it into the frame by folding the wires and pushing them out of the way of the edges so it can snap into place. You should be able to see the head and tail lights peeking out through their holes. For the antenna, modify it by desoldering the flex PCB part of it and stripping the outer enamel with shielding off the coaxial cable, revealing 1.5 centimeters of enameled signal wire. Connect it to the microcontroller and bend it to fit around with a part of it squeezed into this gap. Shape the end so the top cover with its ESP-FLY sticker can fit over and clip into place, leaving the stripped end of the coaxial cable protruding out. That is your antenna. For the landing gear, we'll strip 0.5 centimeter of the enamel off the ends of these solid wires. Shape each into a V with tweezers. Add a drop of superglue into each hole at the bottom of the frame and shove each of these in, keeping them secured. If the drone rocks back and forth like a wobbly table would, simply pinch each short leg with your pair of tweezers or flatten the longest ones to make it sit rock steady. For the last part of the assembly, throw on the props. If you've attached these correctly, the props should spin inwards when seen from the front and rear, generating lift. To program the drone, head to your computer and hook it up via a USB-C charging cable. To flash the phone control firmware, you're going to need to install the ESP-IDF PowerShell by heading to this page, which I've linked in the video description. Download the installer for the 5.0.7 version, open it, and go through the straightforward installation process. Make sure you enable all of the options as seen on my screen. Once installed, the PowerShell should look like this. Next, download the ESP drone firmware I've also linked in the description. Open up the folder and go into the ESP drone subfolder with the core firmware. Right-click up here and copy its address as text. Then go to the PowerShell, type cd space and paste the address pressing Ctrl-V on your keyboard. Hit enter and on the next line type idf.py-p and go to your computer's device manager under the ports drop-down to find your drone's COM port. Type it in, followed by flash monitor. Hit enter on your keyboard and it should flash the firmware to your drone with a log appearing indicating things are up and running by seeing the ready to fly message. Ignore all the errors highlighted in yellow, but ensure the motion sensor's connection is okay, along with its access point network name and password appearing. Now you can unplug the drone and power it up with its battery somewhere flat, allowing sensor calibration to take place, which is indicated successful by all motors spinning up briefly one at a time. To control it, you need to install the ESP Drone app, which you can get on Android using the link below, or find it in the App Store if you're using an iPhone. If your phone is set to block foreign apps, it may prompt you with a virus threat warning. Just ignore that and install it anyway. To connect to your drone, head to your phone's Wi-Fi settings, tap on its access point network, and enter the password, which is numbers 1 through 8. It should say connected without internet. Open up the app where you get this controller interface and tap on the dual arrow button at the top right to pair with the drone. If you're on its network, it should say connected once successful. To fly it, sliding the left thumb slider up controls the throttle, which regulates thrust. Moving the same slider left or right controls the yaw, which makes the drone turn in flight, while the right thumb slider is for pitch and roll, making the drone fly forward and backward or side to side. In flight, you use all of these at the same time to make the drone fly where you want it to. If you tap the settings icon at the top right corner, you can adjust flight control settings like your preferred controller layout and the roll and pitch trim to correct your drone if it tends to veer off to one side, allowing for stable hover. Then you can enable advanced settings for angle and thrust limits, unlocking higher speeds. The controller settings panel allows you to choose between joystick and phone tilt controls, as well as adjust joystick size. Keep in mind these icons above are disabled in the firmware on purpose. Now, if you're not a fan of flying your drone through a screen, you can pair a proper radio controller instead. Using ESP32 communication or your preferred receiver, you'll get more range, better control, and access to advanced features like acro mode, PID tuning, rates, and full beta flight configuration. I've linked a detailed setup guide in the description where I show how to connect the transmitter and configure everything step by step. For flight time, the included 250 mAh battery gives the best performance, balancing capacity and weight for the longest flights the ESP-FLY can push. Alright, now we're getting a little battery warning. I'm having to apply a little bit more throttle. Oh, almost 5.5 minutes. Impressive. To charge the included battery, just leave it plugged into the drone and connect it to a phone charger, the same way you would when programming it. If you have multiple batteries, use a dedicated 1S charger that can charge several cells at once and even balance them to a safe voltage for storage. Weighing in at just 25 grams in flight with 68 grams of thrust, it reaches a 2.7 to 1 thrust to weight ratio, strong enough to handle light winds and fly confidently outdoors. With a top speed of 40 kilometers per hour, it's fast enough to keep things exciting, especially if you invite a friend to race your ESP-FLYs head-to-head. Its head and tail lights keep the drone visible at night, making it easy to maintain orientation and fly farther during line-of-sight flights. Range is another strong point. Within line of sight, you get over 50 meters using your phone, around 200 meters with a radio controller via ESP Now, and over a kilometer with a dedicated receiver. As seen in the previous ESP-FLY project video on my channel, you can add a camera to turn it into a micro FPV drone with this analog 5.8 GHz all-in-one camera and video transmitter unit using the dedicated cover with a mount included in the kit. The camera pairs to a 5.8 GHz FPV headset, letting you see and record live video directly from the drone as you fly. The ESP-FLY has just lowered the barrier of entry for getting into building drones, so whether you're looking for a nice gift for someone or want something fun to build on your own, again, the link to purchase the ESP-FLY kit is available in the video description below. Thanks for watching, and I look forward to hearing how your ESP-FLY drone turns out. Happy making!